Hello, we're going to look at graphing piecewise and step functions in this lesson. Before I start, I want you to do the first few matching questions. Match the line with its equation. We'll go over those in class. And what we're going to do is we're going to have a bunch of new vocabulary you're probably not familiar with. We're going to identify and graph piecewise defined functions and step functions. Well, let's start with piecewise. Piecewise is exactly what it says. We're going to have like two lines on the same graph. We call them piecewise linear functions because they're both going to be linear. So we're going to graph both the lines on the same graph. It just depends where you're at, and that will tell us what rule you should use. And let's take a look at a problem here. And I've got to get to the next page, sorry. Okay, so I've got two equations on the same graph. And it all depends on what side of one you're on. Notice, first off, when it's written like this, f of x, this is your y, and then your x's come second. It's kind of backwards from what we see. So this is my domain, and my range are going to be my y's. Everything depends on where you're at in comparison to 1. Notice, if you're less than or equal to 1, I'm going to use 2x plus 4. If I'm greater than 1, I'm going to use negative x plus 3. When you see a line underneath the inequality, like you do here, that means it includes that point. If there's no line, we're actually not at that point. We're not including that. Now let's forget about slope and y-intercept for now on these piecewise, and let's go back to the trusty table. So what I'm going to do here is first I'm going to make a table for my first line. X and 2x plus 4. I want to pick numbers that are 1 or less. So 0. And remember, I know it's a line, so I only need 2 points. And remember, we're including the 1 in our graph because of that less than or equal to. So 2 times 1 is 2, plus 4 is 6. Maybe I should write how I got that. I took 2 times 1 plus 4. In the next one, I'm going to take 2 times 0 plus 4, and that will be 4. So I'm going to graph 1, 6 and 0, 4. I know it's going to be a line. So I'm going to go over 1. I'm going to make my grid a little bit bigger so it's easier to see. Over 1 and up 1, 2, 3, 4, 5, 6. Over 0 and up 4. 1, 2, 3, 4. And then I draw half a line. I'm going to start at 1 and I'm going to go to the left. So I'm going to graph my line starting at 1 and going through 4. And I got all those points to the left because anything less than 1, I'm going to use that table for. Now I'm going to make a different table for my other line. So I'm going to do x, and I'll do negative x plus 3. Now I'm going to put 1 in my table, but I don't include it. And we'll talk about what do you do if you don't include it. What does that mean? And then I'll pick a number bigger than 1, like 2. So now I'll put that in. So I'll say that's the opposite of 1 plus 3. That gives me 2. Then I'll do the opposite of 2 plus 3. And that gives me 1. So I'm going to graph 1 and 2 and 2 and 1. Now, what do I do because I'm not including this point? What I do, I put an open circle right on it. This means I'm not including the point. I'm starting at this point. I'm just not including it. So I'm going to put an open circle over 1 and up 2. It means I'm not including that. In fact, I think I'm going to make my line a little bit smaller or thinner so it's easier for you to see. And I've already forgot because I'm absent-minded. 1 and 2. So I'm going to over 1 and up 2, open circle. Now my next one is going to be a closed circle because that's on the line. Everything is on the line except the open circle, except for that endpoint. So over 2 and up 1. Then I'm going to draw my line going through those 2 points. Notice I've got 2 lines. And we just have to look at the endpoint. Now, if your endpoints overlap, obviously something that's filled in will cover up something that's open. But this is not continuous. You could not draw this graph without lifting up your pencil. But this is what we call a piecewise function because there's 2 pieces to it. You might have a whole bunch of pieces, but this one has 2 pieces. And the confusing part about this is you have to understand what that line underneath your inequality means. So if you got that line underneath the inequality, we have to notice we include that one. We don't include the point if it's not under there. Now, the second type of graph we're going to look at is called a step function. And if we look at the picture down here, you can see, hopefully you can see, while it's, darn it, I wanted to keep on clicking on the wrong one. Okay, I can see it's called steps because I have steps here, like I'm climbing the steps. Now, one of the most common ones you'll see is called the greatest integer function. Or sometimes, first of all, let's talk about the symbol. Looks like I got double brackets, don't you? If I zoom in on that, a little bit easier to see. It's like almost like we have 2 parentheses. Sometimes you'll see it written, like if you do it by hand, or you use a math font, it'll look like that. It's also called a ceiling function because it's the top it can be. And in a greatest integer function, what happens, it's the greatest integer that's less than or equal to x. So what that really means is we round down every single time. So for example, the greatest integer function of 4.2 is 4. Because I picked the biggest integer that's less than or equal to that number. And then the greatest integer of like negative 5.2 would be negative 6 because negative 5 would be bigger than negative 5.2. And so we'll take a look at how we graph that. But what happens is we graph these points. And notice once again, see on this one, we got those holes. Keeps on not. There we go. When I got the holes, I'm not including that point. So this point, like from 0 to 1, but you don't include 1. When you get up to 1, then we jump to 2. And we'll do a graph like that on the next video.